Imagine a weapon, not a real one, a thought experiment. The weapon is wired to a quantum event, something simple. A particle that either decays or it doesn't, 50-50. If the particle decays, the gun fires, you're gone. And if it doesn't, congratulations, you survive. You hear the click of an empty chamber. Now you pull the trigger and you hear the click. You're alive. So you pull it again. It did not fire. Again, it did not fire. 10 times, 100 times, 1000 times. The probability of surviving 1,000 consecutive quantum flips is effectively zero. You should be dead. And yet, here you are, holding the weapon, hearing the click, still breathing. Hold on. You're saying that someone could just keep getting lucky? That's not a thought experiment. That's just bad statistics. You're right. In any single world, you'd be absolutely dead. There is no second thoughts about this. Math is absolutely clear about it. But what if the world isn't single? What if every quantum event doesn't choose one outcome but splits the entire universe into two, one where the particle decays and one where it doesn't? And what if your consciousness can only ever ride the branch where you survive? It's a conclusion that sounds completely impossible, like it violates the most basic rule of being alive, that living things die. And yet, this is one of the deepest truths about our universe. To understand why this idea exists and why physicists just can't dismiss it, we have to start somewhere uncomfortable: the measurement problem. At the quantum level, particles don't behave like tiny solid objects. They are described by something called wave function, a mathematical structure that holds multiple possible states at once. So like a particle can be here and there at the same time, not just here and there, spinning clockwise and counterclockwise, decayed or not decayed. All of these possibilities live inside the wave function simultaneously. But that's metaphor, right? Like it's not actually in two places. It's just that we don't know which one until we check. That's the intuitive assumption. And it's wrong. This is superposition. And it's not a metaphor. It's not a philosophy. It's most precisely tested theory in the history of science. The particle genuinely doesn't have a single position until something forces it to. And yet, when we look, we never see a blurred cloud of possibilities. We see a single outcome. One particle, one place, one reality. Somewhere between the mathematics and the world as it appears, infinite possibilities seems to harden into a singular fact. But what causes that? What collapses the wave function? That's the measurement problem. And the honest answer is, after nearly a century, we have no idea. For decades, most widely taught answer was Copenhagen interpretation. It said that wave function evolves as a spread of possibilities until one observation takes place. At that moment, it collapses into one actual state. Before observation, multiple outcomes remain alive. After observation, only one remains real. So, just looking at it changes the reality? That's one implication, but inside that apparent simplicity is a deep, unresolved instability. The mathematics themselves don't specify what counts as a measurement. They don't tell us where the line sits between the quantum system and the classical observer. They don't explain whether a detector is enough or whether a conscious mind is somehow necessary. Wait, so nobody actually knows what observation means in like actual equations? Nobody knows. And that created a crack in the foundation. In 1957, a graduate student named Hugh Everett III proposed an answer that was radical precisely because it refused to add anything new. Instead of modifying the equation, he took them more seriously than anyone else wanted to. And his suggestion was devastatingly simple. The wave function doesn't collapse, ever. Wait, so it just keeps going? All probabilities just stay? All of them. Every possible result of every quantum event actually occurs. Reality doesn't narrow into one history, it branches out. Okay, but that sounds insane. Why would anyone believe that? Because it's the only interpretation that doesn't add anything to the math. Everything else, Copenhagen, pilot waves, objective collapse, has to insert something extra. A mysterious collapse trigger, a hidden guiding equation. Everett's approach is simple and says the equations already work. Let's stop pretending they stop working when nobody's looking. Now, this interpretation became known as the many world interpretation. Under this view, the universe doesn't choose one path or erase the rest. It unfolds into a vast, ever growing structure of parallel, non interacting branches. Each branch contains one outcome that appears singular from the inside. So every time a quantum event happens, there's a version of reality that went one way and another version where it went the other. Yes, and these branches became isolated from one another through a process called decoherence. And that's why the world still feels stable and classical. You don't see alternate cells walking through your kitchen. The branching isn't dramatic, it's quiet, mechanical, absolute. But if branches are real, why can't we ever see them? We can't see them because of decoherence. Decoherence locks them apart. Once the environment records a definite outcome, interacting with a particle in a way that distinguishes the branches, the different realities became causally sealed from one another. They don't disappear, they just stop being able to talk to each other. Now, this is where the theory stops sounding abstract and starts becoming personal. Because once you accept that every outcome happens somewhere, a disturbing asymmetry emerges between the world as described from the outside and the world as experienced from the inside. Inside versus outside, what's the difference? The difference? From the outside, all branches exist equally. Some contain your death and some contain your survival. But from the inside, you can only experience the branches where you are still alive to experience anything. And hidden inside that asymmetry is the seed of quantum immortality. Let's return to the weapon. Philosophers and physicists formalized this as quantum suicide thought experiment. The setup is brutally simple. A device connected to quantum event. If option A, you die. If option B, you survive. Each time you pull the trigger, your fate is directly tied to a random quantum result. Under ordinary single-world physics, this is just a deadly gamble, worse than Russian roulette. Each pull gives you a 50-50 chance of proving your mortality. But under many worlds, everything changes. The quantum event doesn't prove one outcome, it causes reality to branch. In one branch, the weapon fires. You're gone. In another, it doesn't. You survive. Both outcomes happen, but in a different branches. From the outside, both branches are equally real. There are worlds where the experiment ends with your death and worlds where you live to hear the click. But from the inside, from your viewpoint, you always survive. That cannot be right? Someone would find your body. You'd be clearly dead in some branch. Bodies are found. In those branches, there is a corpse. Other people grieve. The experiment worked as expected. The particle decayed. The gun fired. The person died. All of that is real. But the person who experienced that death, they don't persist in that branch to register it. Their consciousness, if it continues at all, can only continue somewhere. And the only somewhere available is the branch where the gun or the weapon didn't fire. So the body is dead, but the awareness just moves. It doesn't move. That's the wrong metaphor. It's more precise to say there are multiple future observers that all share your past. Some of them die, some of them don't. The ones who die stop having experiences. The ones who survive continue having experiences. From the inside, you only ever find yourself among the survivors because those are the only ones still finding themselves at all. If every lethal quantum event creates at least one branch in which you survive, and if your consciousness can only ever continue along the branches where it remains conscious, then subjectively, you never experience the moment of your own death. So you just keep hearing the click forever. Forever. From the outside, the death still happens. In fact, it happens often. Other people still lose you, bodies still fall, tragedy strikes, but your own perspective appears to be tracked. again and again and again into the improbable narrowing branch where the story hasn't ended yet. This feels like a cheat, like we have defined you in the way that makes it true by definition. That's exactly the right instinct to have. Hold on to it. We'll come back to it. Now, let this sink in. Okay, before I go forward, answer this. When I say quantum immortality or immortality in general sense, what do you imagine? Do you imagine eternal youth, a body with unified consciousness that goes functioning forever? I mean, yeah, that's what immortality sounds like. But the logic of this theory doesn't care about comfort or dignity or health or even identity. What does it care about? It only cares that some strand of awareness remains, just enough consciousness to preserve a point of view, just enough neural function for experience not to collapse entirely into nothing. And that threshold may be horrifyingly low. How much? How low? You don't even need to be a whole person to count as a continuous. You don't need to be well physically or mentally. You may only need to still be there. That's not immortality, that's a prison. Exactly. And this is why some philosophers describe the end point not as immortality, but as a kind of probabilistic ghostliness. If the body deteriorates, consciousness may not continue as clear, uninterrupted stream. It could fragment, it might shatter, it might thin into discontinuous flashes, brief windows of awareness opening inside longer fields of confusion, pain, sedation, amnesia, neurological ruin. Perhaps what persists is not a stable self moving cleanly through time, but a sequence of degraded moments, each barely sufficient to count as a continued observation, not a life, intermittent residue, not eternity in grand sense of scheme, eternity reduced to broken frames, a mind that cannot fully die but can no longer fully live either. So it's not that you live forever, it's that you cannot escape. There's also the problem of isolation, and this may be the cruelest consequence of all, because even if your consciousness continues, everyone else still lives inside the branches where you don't. Your family mourns you, your friends miss you, the world reorganizes itself without you. And those people, are they the real ones or are there copies of them too in your branch? They are versions of them. Whether you would experience those versions as the real people you would love or as hollow copies in world where you have already watched yourself outlive everyone, that's the horror. The people you love don't become immortal just because your awareness keeps slipping forward into narrower, more improbable probabilities. So, the longer the process lasts, the more separated you become from the human world that once gave your survival meaning. So, this is actually worse than death, potentially. We fear death because we assume the opposite of death is life. Quantum immortality suggests the opposite of death may simply be more experience, and those are not the same thing. There's another problem buried inside this idea, and it cuts deeper than the fear of endless damaged survival. Even if we grant the full logic of many worlds, even if we assume consciousness always continues along some surviving branch, it still doesn't mean the thing continuing is meaningfully you. What do you mean? What else would it be? We talk as if identity is obvious, as if a person who wakes up tomorrow is simply the same person who fell asleep tonight. But that confidence rests on something surprisingly fragile: memory, bodily continuity, psychological coherence. These are the threads from which ordinary self is woven, and none of them are as absolute as they feel. But I still feel like me every morning. You do, and that feeling of continuity is powerful. But under many worlds theory, every branching creates multiple future versions of the observer. These versions share a common past up to the moment of divergence. But after that, they accumulate different experiences, different conditions, different endings. At first, different might be macroscopic. In one branch, a particle decays, in another, it doesn't. But over time, these small divergences compound into radically distinct lives. Different injuries, different environments, different memories. So there's no real one. Identity under branching becomes distributive. The self doesn't continue as one line. It proliferates into many different descendants. Quantum immortality quietly relies on trick of language. It says, you will always find yourself in a branch where you survive. But that sentence only feels intuitive because the word you is doing way too much work. Which you? The present observer imagining the future. The future branch that retains enough continuity to feel like a successor. The set of all descendants with some claim to your history. Once branching becomes real, identity no longer behaves like a single thread pulled intact through time. It behaves more like a tree, and trees doesn't have one future. It has many. Some branches flourish, some terminate, some twist into distorted forms that still emerge from the same trunk, but no longer resembles the shape you expected. The theory doesn't guarantee your personal immortality. It may only guarantee that among your many descendants, some consciousness remnants continues. So, where does this leave us? Quantum immortality is probably too unstable to believe. Many physicists reject it, and even many of those willing to entertain many words don't accept the subjective leap it demands. So, why are we even talking about it? Because studying it reveals something in us. And what does it reveal? Our desperation to imagine consciousness as something more durable than our flesh. Our instinct to treat the self as fundamental, even when neuroscience can't prove it. Our refusal to accept that death may not be a puzzle with a hidden loophole, but simply a boundary built into the kind of beings we are. So, we are not actually talking about physics anymore. We're talking about fear of death. Oh, we're talking about both and the way they tangle together. Quantum immortality is not powerful because it proves immortality. It is powerful because it weaponizes our uncertainty about what a person is. And that's why the idea feels so hard to dismiss emotionally. Even when it's weak scientifically, it attaches itself to something older than reason. The raw, first person fact that no matter how much you understand death in abstract, you have never experienced your own absence. You have only ever experienced continuity. Yes, one moment leading into another, one consciousness frame dissolving into the next. However rationally you accept mortality, experience itself keeps teaching the opposite lesson. You can imagine your funeral, your absence from other people's lives, your body decaying, your name fading. But all of that is still imagination happening from within your awareness. The one thing that you cannot represent from the inside is the total disappearance of the representer. So we are kind of trapped in our own perspective. We can't really even think about not existing. That's it exactly. And that's what the idea exploits. There is a hidden mercy in finitude. The old human dream was that death might not be final, and that finality might just be what gives life its meaning. If your mind is still untangling itself from this one, seriously, we'd love to know where you landed in the comments. Did this make death feel more acceptable, more terrifying, or both? And what other physics paradox or mind bending concept should we pull apart next? Thanks for watching.